Elon Musk was on Lex Friedman, and he said something interesting. He said that it's really important to have robots with low compute per watt. And what he said there, I think, is much more profound than most people understand. And where I'm coming from here, I'm doing my sabbatical now at Stanford, and I'm spending a lot of time with the robotics people. And I think I'm going to try to summarize my thesis and tie it to Musk's comment. I think that robotics as a field is going to progress a lot once we have enough robots out there that other robots can learn from. And we need to bootstrap this field, and that is what the robotics community is working on currently. I'm going to discuss some of it in this episode, and then also in the recap for the week. There was CORL, the conference in Atlanta, and there's also a bunch of seminars I attended, and MURIPS is coming up. So there's a lot of meat around the bone here when it comes to what the robotics community is doing right now. I think one of the main tasks of the robotics community today, as we speak, is to bootstrap a fleet of robots, so then we can use the data to learn. Very similarly, how we bootstrapped text or language or NLP through the internet, and then models like Llama, ChatGPT, and so on and so forth came out, Grok, that are now able to pretty much solve the Turing test problem. So now, what does that have to do with Musk's comments? I believe that Tesla is very well positioned, actually, to be that place where we bootstrap the robots, because low cost is going to be key in scaling up the robotics community. And low cost compute per watt, for example, is one of the main issues. Of course, the other is actuators and so on and so forth. This is not even on podcast. It's November 10th, 2023. This is Krim Delco. Since the last update, we're down 2.5%. The market is up 1%. For the year, we are up 88.4%. The market's up 14.4%. We're outperforming by 74%. So Musk said that compute per watt is one of the key ingredients of the Tesla AI slash hardware effort. And this is very, very important, because if we look at the AI efforts so far, the big AI companies, the companies that dominate AI, which are Google and Facebook and newly also Microsoft slash OpenAI, they're all in the virtual space. They're all in the text space. They all have server farms and training methods and inference methods at their disposal that haven't really brought the question of compute per watt to the surface. It's there. People talk about it in academia. Onur Mutlu talks about it. Philip Wong here at Stanford. So the ability to have more efficient compute, to deal with memory, data-centric compute, all of these things are certainly part of the equation. Last week's seminar about adaptive, semiconductors, trying to do neuromorphic compute. All of these endeavors are going in that direction, but nobody is actually trying to optimize for compute per watt. And I think Musk is trying to optimize for that, because he has a car that is a robot, and he's going to have a humanoid robot, or he's working on it right now. So we need to optimize for that. It's compute per watt, which is only one cost vector. Of course, there's also the actuators, there's the material. There's also the ability to build robots that don't break all the time, because they will break, particularly during learning processes. So there's a lot of material technology that needs to be evolving. There's a lot of, there's a lot of vectors here. This is a multidimensional vector space, and the optimization is going towards building robots at scale. And the reason we need robots at scale is because we can then learn from them. So once we can bootstrap this field, I think we have a chance for having real-world AI in a real human sense. Now, whether that leads to AGI and all that, that's not part of this conversation here. I believe that embodied systems have a chance to develop an intelligence that is certainly more human-like. This goes back to the seminar about East Asian philosophy I saw this week. where the professor was talking about embodiment and intelligence as a prerequisite for actually having intelligence. So these are all, again, like I think, very fundamental, interesting questions that I'm going to discuss a little bit in the recap of the week. But in this particular episode, I just want to mention this fact, which is that we believe that Tesla is very well positioned to become a leader in robotics because they have a vision to reduce the cost per watt, per robot, per move, whatever measurement you want to use. They're reducing the cost so they can scale up, so they can have a system that can then that can be bootstrapped, so we can have a bunch of robots and then a lot of robots and then even more of them. And the more we have, the more they can learn from each other and the faster we can progress in this field. This is the central thesis of Orange Capital Partners as far as we're investors in Tesla is concerned. I think it's also an interesting conversation. When I talk to academics here at Stanford, this question always comes up, and the answer is most of the time we don't know. Now today, I actually had the chance to attend a presentation by a gentleman who is professor at Beijing University, and I was stunned how optimistic he is about the Tesla endeavors. And it just makes me think that there is an inert, almost anti-Tesla feeling here at Stanford or generally in US academia, and that is not shared with Chinese academia. The Chinese are going full frontal towards robotics. They don't care about legacy. They don't care about Elon Musk. They don't care about none of that stuff. All they want to do is succeed, and they are going towards the same route of having lots and lots of data, lots and lots of training data, lots and lots of examples, and for that they need lower cost. Now, I'm not sure about the low cost situation there, and I wasn't able to talk too much to the name eluded me. I'll put it in the show notes to the professor. But that's also not the point. I'm not talking about competition here. Of course, Tesla will have competition sooner or later, and we'll talk about that when time is due. Right now, I think we just want to sort of get the point across. This is what's really important here. That when you want, in the wealth generation business, what you need to do as an investor is understand when the prerequisites are laid, the foundations are laid for future technologies that build on each other and that will create this virtuous cycle of technology building on top of each other. That's when wealth is created. And that's almost, I don't know if there's a theorem there, some sort of like Miller-Modigliani theorem or something, where you can almost prove mathematically that this is how wealth is created. That's, again, not the scope of this episode. I think the purpose of this podcast series is to give people a sense for what it feels like to run a hedge fund. It's not investment advice, so please please do your own work. Don't contact us based on this episode. We're not interested in raising money, none of that stuff. The purpose of this episode is to give people a sense for what it feels like to run a hedge fund. We're in the wealth creation business. The purpose of Orange Capital Partners is to generate wealth with fundamentally new concepts and engineering practices. Now, you're only going to generate wealth if you can build on top of other technologies. You literally have to build on the shoulders of giants. And this is a perfect example where we're building a giant. We're building a giant, which is we're building a fleet of robots that is going to learn how to move in the world, how to do tasks, and then other robots can learn from them, and so on and so forth. And for that, we need a low-cost robot. We need low cost to compute per watt, and we need low cost of actuators. Musk spoke about this in the Lex Fridman podcast, also in the show notes. And I think this is just another reminder of the difference between academia and business. Okay, academia, as far as I'm concerned, is doing a lot of scratching the surface type work. Okay, and some of them are doing more fundamental work. Let's say I've attended a lecture by Fei Miao from University of Connecticut, and she's more of a statistical, foundational mathematical person that thinks about game theory and multi-agent behavior. She's building foundational models to decide what is robustness, what is uncertainty, how can we increase uncertainty in a traffic system, those sort of things. And these are important things. I attended another lecture today about a gentleman from Carnegie Mellon. Name eludes me right now. I'm going to put it in the show notes, and it's going to be in the formal conversation about the week, so don't worry about that. I'm going to discuss it. But my point here is he is talking about how to learn, how to efficiently learn tasks in a continuous learning process, which is a very, very interesting problem. Okay, how can I add parameters and weights or variables to my model without destroying what I already have? So there's a lot of that stuff, but the gentleman in the morning that I just mentioned a while ago, the Beijing professor, he is working on simulation as a solution to the bootstrapping problem. So this is the big debate right now. Are we going to simulate our way out of this, or are we going to have real world examples? I think Tesla is on the cusp of getting real world examples because they have a foundational model, which is the full self-driving car suite. Now, it's not exactly a robotics suite in the sense that dexterity with fingers doesn't exactly transfer from the full self-driving car, but depth does. And this is so important. Depth is a crucial problem in robotics. When I see something, I have to have a sense for how deep it is, how far do I have to reach in order to grasp it or to avoid it, and so on and so forth. That is absolutely important. That is a problem that Tesla is solving with the car and transferable into robotics. And again, it's not just about the model, it's not just about the AI, it's also about the mindset of having low-cost, scalable robots. This is going to be able to bootstrap the robotics development at Tesla and, of course, also around the world. So to summarize, in order to create wealth, you have to build technologies on top of other technologies, and this has happened many times before. Amazon has built on top of the internet, Apple has built on top of flash drives, and many other innovations. Of course, Moore's Law has been a driver for all of these companies. Tesla is building on top of, as far as the AI is concerned, it's actually bootstrapping itself by building low-cost computers, low cost of compute per watt, low cost of actuators, and transfer learning the data from the car into the robotics space, in particular depth, and then building robots, having lots of robots out there doing tasks, learning from them, and then bootstrapping itself into a real-world AI company. Thank you.